All right, everyone, welcome to DBA Fundamentals. This week, we have one of my favorite presenters of all time, moi. So I don't, so I don't like to talk too much about things that what I do. If everyone can please remember to actually turn off your mic. Yeah, so let's go ahead and get started. As I said, today we're doing finding the right data types. Hopefully you can learn more about data types, when to use what ones, what actually data types are, everything about it. So I am the speaker. I am Kevin Wilkie. Today is October 7th, 2025. In the top right-hand corner of the screen, you'll see all of the leaders of the DBA Fundamentals group, Steve Cantrell, Shane O'Neill, and myself. To the right is our X handles if you need to get hold of us for any reason. Below that is our various social media platforms. We are always on. Obviously, most of you found us today's presentation on meetup.com. Be sure, if you haven't already, be sure to follow that so you can see all of our presentations as they become available. I'll be putting out some for the new year very soon, so we can start learning more about all kinds of goodness with the upcoming year. Below that is our website, dbafund.com, where we have all of our presentations, even some of our past ones. For those of you who haven't been with us for quite so long, we actually have over 10 years of our past presentations out there. So if you have anything, because as we all know, probably not working with 2025, SQL Server 2025 yet, we still have stuff for SQL Server 8 out there. Because it's still in use. I've worked with a client recently who still has 2008. Not long ago, I actually worked with one that had SQL Server 2000. So yeah, all kinds of fun. We have all kinds of stuff like that out there. Be sure to also look at our website, our YouTube site, dbafuntube.com, where you can see all of our presentations. Be sure to like and subscribe to it so you can get the today's presentation whenever it's actually put out there. Below that is our other social media handles on X, we're DBA Fun, our Slack channel, and our LinkedIn group as well. Some of our upcoming conferences I want to point out in just a couple of weeks. On the 19th through the 23rd is Community Summit in Orlando. Always a fun time. Any reason to go down to Orlando is always a good time. So knock that out if you can. And then in November is the big one in Pass Seattle. There is going to be the Pass Data Community Summit, where there is a lot of conversations and stuff to be had on anything from Fabric to SQL Server to anything in Azure. If you have a question, that is the one to go to and think about going several times for just for networking alone. It is well worth your time and money. I know I'll be out there this year speaking on Fabric, so that should be fun as well. So with that, remember to turn off your video and mute yourself. I'll probably actually turn off my video here in a few minutes. I'll obviously keep talking so we can talk through what we're seeing on the screen. If you have any questions, be sure to type them into the chat. I won't look every minute, but I'll keep a pretty good close eye on things like it. If you have any questions, be sure to ask. At the very end, at least, I'll answer as many questions as I can. Here's me. I've done all kinds of stuff. So with that, let's actually move over to my real presentation. Stop sharing for a second while I stop that one. Go to my real presentation here. All right, back to sharing. All right, so let's talk about finding the right data types. There are lots of data types. We've all dealt with data types for quite some time, but do we really know some of the gotchas, some of the reasons we do things, some of the reasons why we pick others, and what all we can do to make life easier and why we do those. So with that, let's go right ahead. As I said earlier, I am the presenter. We're going to talk about, I've been doing SQL Server now for over 20 years. Also blog at sherpaofdata.com. I talk a lot about Snowflake, AI, SQL Server, agile experiences, you name it. If I've done it at some point, I'll talk about it on there. Obviously, I also am the co-organizer of DBA Fundamentals, since that's the group we're in now. Over the years, I've held lots of titles, such as ETL developer, production DBA, BI associate, blah, 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 blah. Yeah, lots of stuff. I've been doing this for a while. So let's talk about data types. Truly, when we think about data types, we only think what it's a classification of what type of value a variable or a field can hold. But it's also the type of operations that can be performed on that value without causing errors. Because there's nothing worse than just having a type out there and not being able to do anything with it, which does happen. I've seen that happen. It's not pretty. So with that, there are 5 types. Well, I classified 5 different types of data types: character strings, exact numerics, approximate numerics, date, time, and other. Yes, other is large in some cases, but it's the easiest way to hold some of this stuff. So as we go through this, I'll actually break it down in 3 different types. So I'll talk about SQL Server, Oracle, and Snowflake. Most of you probably have not had the opportunity to play in Snowflake. Hopefully we can get you at least a basic idea of how Snowflake compares to SQL Server and the differences between those. All right, let's talk about character data types, because there is a lot of stuff here. We mostly got to play with it ourselves a few hundred times. So the first thing is a car. I refer to it as car. I've heard it referred to a couple of other different ways, like chair, I've heard. It's all, as long as you pick a way, I'm good with it. I like car. It's just the way I was taught. There's also VARCHAR, which is actually a variable width as well, character being a fixed width. There is a slight difference between those, and it's truly just what it is behind the scenes. NCAR, which is Unicode fixed width, and then in VARCHAR, Unicode variable width. Now, having said that, as of 2019, SQL Server 2019, you can put Unicode data into VARCHAR or CAR in one case, and that is if the collation for the database is set to _UTF-8. It has a suffix of _UTF-8. That will allow you to put the data in there, and you can continue on. The drawback to that, though, is it's not performant. It's not as performant as NVARCHARs or would be. Yes. So Michael, I see you put in the chat, does this mean presentation is applicable to Postgres? Some of it is. I'll show you some of the places where it can be. There are some nuances between Postgres does do slightly differently, but it is very comparable to Snowflake. You'll obviously have to see the differences and work with it just to make sure, as I'll show as we go on. SQL Server also has a text data type. Do not use it. Please don't use it. It's been quote unquote deprecated since 2005, but I still see a lot of groups out there that actually still use text. It's different. Microsoft actually has the ability to deprecate it in any future version, But as you see, they started saying it could be deprecated in 2005. So next year, it actually turns old enough to the fact that it could be deprecated is going to be old enough to drink. So maybe we should all tip one back for that for Microsoft because they're waiting on that one for some reason. All right, Oracle. Oracle is a little different than SQL Server. It has CAR, which is to fix with. It has VARCHAR, but then it has VARCHAR 2. So several years ago, I believe 2010, don't quote me on that one, Oracle actually tried to deprecate VARCHARs. It could truly be gone completely at some point, and they might do it, except for the fact that two things are working against it. You have some really old code out there that is still using VARCHAR and no one has touched it forever. And then you have SQL Server people that come into it and they just go to VARCHAR because they don't know VARCHAR 2. That is working against it. So this truly might never be deprecated. But it's a good practice with Oracle. If you're having to play with it, go for VARCHAR 2 if you can. It will make a difference. It's way better for you if you use VARCHAR 2. They actually also have an NCAR, which is for Unicode, and they have in VARCHAR. So it's pretty close to what we have in SQL Server. But then you have CLOB, which is a data type that stores 8 terabytes of character data. And they have nclob, which stores 8 terabytes of Unicode data. So those two are closer to text, if you've ever had to play with that. So in reality, yes, Oracle still has a variant of text. All right, Snowflake. Snowflake is fun. It has car or character. You can call it either one, data type. It works just like a varchar. String is very synonymous with varchar. Text is varchar. In varchar is varchar. Yes, let me repeat that. In varchar is varchar. Varchar itself is truly a variable width. It is truly 16 megabytes of data. So you can call it car, you can call it string, text, in varchar, varchar. When you look at the table description afterwards, it's all going to show as string. That's really all it does. That one, if the other fun part of that is if you don't define how large it is, it will default to 16,777,216. So yes, by default, it can store the entire 16 megs of data, which if you've looked at table sizes and whatnot or care about those, you've eaten up a lot of space real quick. So something to be aware of. All right. Make sure. Yep. All right. So with that, I actually have a demo I want to show. All right. So with character, this is, yep. So with that, I've just created a small temp table. And you'll notice here, first name is a varchar, last name is an in varchar, both of 30, and the full name is 75. Pretty simple. All right. Now we're going to insert some data into this temp table. We have Fred Flintstone, Barney Rubble. Older people out here will know exactly who those are. Then we have some really long names. I made sure these were very long. They were way over 30 characters. Long first names are really my specialty. So when we go to create that, push this into SQL Server, it errors. It gives you this fun error. String or binary data will be truncated in the table, temp table, and it shows the complete name of the temp table, tell you what column and the truncated value. It shows you up to what point it would be truncated to. Some of you older people out there, or some people who have been stuck using older versions of SQL Server, You'll know this wasn't always the case to get all this good information. This actually only started in 2019. If you go to a version of SQL Server prior to 2016, you will get a very less helpful answer. You will get a string or binary data will be truncated in table, and that is it. I believe it's actually would be truncated, and that's all you get, period. Not as helpful, not great, but at least it did tell you you get truncated data. Then it's up to you to figure out what field it was in. It's all kind of fun, but this helps. Um, the reason I say prior to 2016 is because you can backport it, your SQL Server to that, and then you have to also make sure your compatibility level in your database is over 2016 to work. But for sure, anything 2019 and beyond works no problems. So with that, let's actually make this where we get the data in there. Our little two rows are inserted, Fred and Barney. Pretty simple. So yes, Kurt, is it possible to adjust where the truncation happens if you want to always include the last letters? For example, can you make the script take the first 15 and last 15 letters from a long name? What you would have to do, work your magic. Um, when you're inserting, you have to play with it yourself. That's the only way. You're not going to get any, because straight out of the box, it will try to insert everything. That's how it works. Simple as that. So good luck to you on that one. Yeah, because that definitely does happen. I see where you're going. Sadly, no, SQL Server won't do that straight out of the box. So now that you see the table itself, and let me actually put this in presenter mode. For those of you who actually see what I'm playing with here, this is SSMS 21. As you can tell by Dart mode. It has a few new features that are kind of cool. I use a lot. And you can tell Dart mode, yay. It worked great. I've not had any problems with it. As you can tell, I work with it every day. All right, so with that, so I've actually shown that this is my table. I'm going to update full name, so you'll see that it is last name, comma, first name. Just insert that into the field so we can look at it, no problems. All right, now we can just look to see the length of full name. You know, these are pretty short, 16 and 14. No big deal, but there is a catch on this one. So remember up here we have VARCHAR, in VARCHAR, and VARCHAR. If you've not played with it before, you'll actually see they're not as the same size you think it will be. So length, as we all have played with before, length just actually shows, if you look at it, truly what the size is. And you see from first name, since it's a varchar, length, data length is how much the data length function, if you haven't played with it, shows how much space how many bytes the actual string takes up in the database itself. You see here for first name length and data length are exactly the same. Last name, on the other hand, is double. The data length is double the length. So you'll take, as we've always said, it takes up 2 bytes Unicode, well, in varchar does, as compared to for each. So let me say that again. That didn't come out quite as English. The data length for in varchar, you'll notice, is 2 bytes for every 1 character. Varchar is only 1 character for each 1 character. That's truly what we are showing here. Let's see. Yep. Okay. All right. So we've got Snowflake out of the way for characters. We've got all that goodness, and we've shown our little demo for SQL Server, so rock and roll. Exact numerics. Exact numerics truly just store exact numeric values. So no scientific values. That's the big point I want to show here. This is exactly what you think. Lots of integers. And then some. So as you see from our first one, we have bits. Most of us don't think of bits or booleans as a exact numeric, but it truly is. As you'll see, it stands for the value true or false. But in reality, it's 1, 0, or null. Yes, in reality, if you haven't truly had to stop and think about it, bits and booleans are trinary. You can have 3 different values in there and it can make a difference. So that's one of the reasons I like to make sure that when I'm looking at a table and the data type says Boolean, it better be not null or they're allowing way more than they think. Yes, Michael, if you're trying to count with Boolean, you have other issues, but it's something to be aware of. When converting from another data type to a bit, any non-zero is true or 1. That is something definitely learned the hard way sometimes. So when you're putting -7, and it will actually change it to true. +7 is also converted to true. And for that case, square root of orange can be converted to true. So you've got to be careful when you're actually making your conversions, putting data into this field. Be aware of it because as we say down here, true and false convert correctly into bit. So be aware to play with it. Make sure you're actually getting the data you need to when you're pushing data into it. One other big thing, this is just for SQL Server. Oracle doesn't have bits. It doesn't allow for it. You do other variations of however you want to show a bit field. And Snowflake before January of 2016, there's also no bit data type. You get to do your own little variation of it. So be aware of that if you have to work with anyone that has had Snowflake created. The Snowflake environment was created before January of 2016. Be aware of it. So when we think of exact number, this is what we think of. Integers are truly just whole numbers. So down here I list both SQL Server and Oracle's variations of it. They actually have the same amount of numbers that can show up. As I'll show here, it's -2 to the 31st power plus 1. The maximum is 2 to the 31st power minus 1. For integer, to have small integer and small int in SQL Server, short integer in Oracle, big int for SQL Server, long integer for Oracle. Now, this is where this little blurb comes into play. SQL Server, these are data types. Oracle, this is a data type, the integer, but short integer and long integer, they're subtypes. So the reason that is very important is because if you take and try to create a table in Oracle and you give it the data type short integer, it will fail because it's, as I said, it's not a true data type according to Oracle. But you can use short integers for creating variables. Play with that one. It's a little special the first few times you see it, then hopefully you remember. If you work in Oracle enough, you definitely will after a while. Same thing goes for long integer. Now, Snowflake doesn't really have integers at all. They're actually shown as a number type, which I actually classify as, in the next little group, we'll talk about decimals. it's something to work with and get used to. You can still, you work with them all the time, but it's a little different. It just shows a little different. It's still, snowflakes you can work with, definitely you can work with integers. All right, so tiny ints. We have, this is only in SQL Server. There is no Oracle variation of this. Minimum value is 0. Maximum value is 255. Notice there is no negative numbers. So that will be very important if you try to mess with tiny ints. Also, this one can come in extremely helpful. So, in my last group, I actually worked in healthcare. We had what were known as episodes. So they were like, I think every 6 months, you could have one episode or could have an episode. The group I worked with, for the most part, you'd max out 10 episodes. We actually used the tiny int for this group because we were able to catch if something went very wrong with our programming and they had 256 episodes, because that would make somebody over 128 years old, and that's just not possible. So we caught a few things like this by using tiny ints. Now, if we had used integer, we'd never catch it, because you can have 3 million of those and not running into an error. But this one, you run into an error much quicker. You could do some other things to catch it quicker, even quicker than just 255, but it was great for us. At least we caught some issues. All right, so now we're going to talk about numbers with decimals. All right, SQL Server, Oracle, and Snowflake all need to know two things when dealing with a decimal number. You need to know precision and scale. Precision is the max number of digits stored. Default for SQL Server is 18. And that way you can show up to 18 numbers for that. And Oracle and Snowflake, it's 38. I know y'all are all real good programmers and actually show your precision and scale every time, but that is what your max number of digits can be for both of these. Scale is the max number of digits stored to the right of the decimal point. Default is 0 for all three of them. But we'll play with that and we'll show you some goodness here. All right, for SQL Server, decimal and numeric is actually the same thing. Negative 10 to the 38th power plus 1 to 10 to the 38th power minus 1. Oracle, the decimal is the same thing. Oracle number is negative 10 to the 125th power. So yes, very large. Snowflake, we have truly one. We have decimal, numeric, number. They're all just the same thing. Something to play with. Let's actually go to my thing, because I actually want to. I have a small demo on a number with decimals. All right, for the below query, if a normal person was to calculate it, what data type would be used? Then more importantly, what data type does SQL Server return? Now, we all know I'm not a normal person. Normal to me is only a setting on the washing machine. So for that, I had to ask a normal person, what data type would be used if we actually created it. So if I'm just looking at it, select 1 divided by 2, so it's a half. It's a number. It's a decimal. Pretty simple. What data type does SQL Server return? As you see, it returns 0. It returns an integer because these two are both integers. Be aware of that as you're playing and showing reports, because that can make a big difference. So now, let's look at these numbers. Select a bajillion divided by 2 as result 1, and this is result 2, because we only added 2 to this one for it. So we look at that, and we're like, these are both going to be integers because there's no significant digits in there. Yeah, sadly, this is where the line comes into play, because this one showed an integer, but this one showed a decimal. So be aware, this is where the line is that you don't cross if you want it to show correctly. This one is barely over. You can play with it. If you need to convert this into a decimal and move on from there, you can do all kinds of things. I think even this one will function, yeah. You just have to divide it by 2.0. That's all you have to do to fix that, the easiest way. All right, so with that, what happens if you go outside the limits for the data type? Let's create our little temp table. Creating our temp table, we're going to create itty bitty number, which is a tiny int, not null. Make sure I did that. Yep. All right, so we're going to insert into our new temp table the number 254. So everybody hopefully remembers that the tiny int holds up from 0 to 255. So we're going to play with that. We're going to insert it into our table. We're good to go. We're actually going to select from our table just so you can make sure I have nothing up my sleeve. 254, exactly what we put in there. So now we want to add 2 to it. Itty bitty number plus 2 would be 256, which is outside the bounds of the data type. It should give us an error. What does SQL Server do? It gives us an error, thank goodness. There is an arithmetic overflow error for data type tiny int. And this one actually does for everything I looked at. So everything at least a 2008 R2, I am pretty sure that this one's always been there. I don't remember ever not seeing it. That doesn't mean it can't be otherwise, but at least I know up to at least 2008, back to 2008 R2, this one shows this way with an error if you try to do this, which is awesome. All right, so now we're going to create another temp table. We're going to create our decimal data type temp table. As you see here, one decimal 74, one number numeric 74. As we saw from our slide, this is actually the same thing behind the scenes. With scale is also decimal 74. I want to bring this out also. If you ever play in Oracle, you can also do negative scales. So negative scale, decimal 12, -2. So you're actually setting the scale to be -2. So therefore, this will only hold hundreds. You cannot, into this field, you could not put tens or ones places. It will just say the heck with it. I'm sure there are cases out there where you need that. I have yet to run into them, but I'm sure over somebody's time, we'll run into at least one use of it. I have yet to though, so we'll see where it goes from there. But like I said, this doesn't work in SQL Server. As you see, it already throws up an error, says that's invalid, that's not going to work. So play with that. It's fun. All right, insert into our decimal data type temp table. So these are just numbers I've thrown in there. There's nothing special about any of those. When you look at them though, you'll see that they've all been cleaned up. Notice this one has even been rounded to our, we put it to a scale of 4, so easy peasy. I've cleaned up the others as well, give them all 4 scales. All right, so how does this affect us when we divide or multiply? So we're just taking one decimal, so this field divided by this field. And then we're going to take this field times this one and give us another number. Pretty simple. We've all done this a few hundred times. You see, this is how it comes out. Nothing special there. All right, so now we want to we'll put some more data into our temp table. Decimal 1 divided by decimal 2, decimal 2 divided by decimal 1, and then decimal 1 times decimal 2. So we can put that into our table and look at it. So this was the row we put in the first time. This is the row we put in the second time. It cleaned them up, put only the first 4 in scale in there. We're good to go. Now, here's where the fun begins. All right. So now what does it return when I do this? We're still working with variables. Select from data type where 1 decimal equals decimal 1 divided by decimal 2. Well, thankfully, that's what I put in up here. So it should return that, right? Run it? Yeah, you don't. Why is that? Well, we all know it's going to be because of significant digits. It just doesn't pull. To make it where it would pull, you'd have to actually play with this. I believe you can actually play with it. I think it has to be out to all 4. See if this will work. Nope. So yeah, anyway, try not to ever do this. Do all of your functionality or give it an exact variation, exact answer. Don't try to figure it out here as you're grabbing back data. It will, because of significant digits and whatnot, it will have to play. Oh, I think you have to do this. I think that's it. We'll play with that. Nope. Hey, get this fun error. Yeah, all kinds of great fun. So you just play with it if you really want to make it return. But this I recommend not ever doing for this very reason. All right, now we figured out decimals. Money, one of my other favorite data types, because as everybody knows, we all like money, money, money. All right, so there are count them, 2 different money data types in SQL Server. Small money and money. Very rarely do you see anybody use small money. It's 99% of the time they'll use money. The reason being because hopefully your data you're going to put in there is going to be way higher than $214,000. Either way. If you're not, and we'll never put anything greater than 214,000 bucks in there, go for it. If you like, if you use the money data type, go for it. Well, in this case, the small money data type. Otherwise, use money. This one's huge. I hope you actually run past this one at some point. Yeah. Side note, Oracle and Snowflake do not have true money data type. They are forced to use number 19.4. Now, let's play with money in a demo because it may change some people's minds. All right, money. We created another temp table. No worries here. We're going to actually put some data in there. Just pretty simple. We have a total and a portion. Great way to actually break this up. You'll see kind of what we're going for here. All the money we put in, money a friend gave us, and then part of the money we put out. Pretty simple. So when we look at this, we're doing see what percentages we got. Pretty standard task here. Select the portion, total, portion divided by the total times 100. We're used to seeing that for percentages all day, every day. Rock and roll. All right, so the good QA in me comes out and says, oh, let's test this one out. So we're going to look at calculator, everybody's favorite Microsoft function, Microsoft app ever. We're going to actually figure out some of these. All right, so let's do number 7 here, just to be different. 967.54 divided by 4936.56. It says 19.59, and when we look at it, 19.5994. In reality, this, because of how rounding works, this should bump up to 19.6. Maybe just Microsoft screwed up on this one. Who knows? So we take 124.33 divided by 265.67, 467,986, which would be 46799, and which is 0.468. Yeah, so there's a reason for this. And it's not completely wrong, but it's not completely right either. So yes, these are edge cases. But as always, you have to play with it because more than likely you're going to run into these a lot more than you think. So this is the correct implementation if you want to work with and get the correct values here. You see for the first one, 46.8, these values actually are correct. So you'd have to change all of your calculations to be like this. I don't know about y'all, but I'd rather not work with money data type and then have to convert it to decimal to do any real work with it. So I try to stay away from money for this very reason. Yep, we're going to do that next. All right. So just want to bring that one up because I see a lot of money data types out there. You have to be careful of those. All right, approximate numerics. Thing we talked about earlier. These actually only represent a real number. They're not real numbers. So I show these, for example, it's pi, Euler's number, and the golden triangle. Golden ratio is what it's really called. There are those, and they do exist, but they're approximate because they're not real things. They're not the exact number, what it should be. One of the things that also is shown is floating point numbers. So when we talk about floating point, it refers to the fact that the decimal point can be placed anywhere relative to the significant digits of the number. I like my example here. The number 1.2345 is in reality 12,345 times 10 to the negative fourth power. That is truly a floating point and how it works, if you can play with it that way. This floating point is great for quantities such as distance between galaxies or distance between atoms. So it's really big things or really small things, not so much the in between. As you'll see, if you've been working for a while, you'll see a lot of developers try to throw things out into your database with floating points that are really just decimals. They're not going to do anything that has hardware acceleration that even comes close to it. It's not, theirs is not a thing. The only reason you should be using true floating point numbers, floating point data types, is if, like I said, you're working with galaxies or atoms. The other stuff, leave alone. It's just doubles or reals. So in here, you'll see in SQL Server, we have both real and float data types. Real is negative 3.4 times 10 to the 38th power. Float is negative 1.79 times 10 to the 308th power. So yeah, it's rather large, can be very precise. Binary float for Oracle and binary double for Oracle do kind of the same things. Pretty close to the same values. I believe I'm missing a negative here. Hoping I did anyway. Snowflake, on the other hand, has floats. They don't. Oh, sorry, I'll read in my note here. They have floats. It's negative 10 to the 308th power times 10, or 10 to the 308th power minus 1. It goes a lot of ways in between. As always, I would recommend not doing floats unless you are truly going to do something that has to use these kind of numbers. Then we have date time. Date time is always fun to talk through because there is so many variants of it, so much stuff to work with and play with as well. Date in SQL Server. These are all SQL Server things. Starts minimum January 1st, the year one. Maximum is 12, what is known as, I like to refer to as the end of time. Date time is January 1st, 1753 to the end of time with 3 digits after the decimal. So I want to bring this one up for date time. 1753 has to be the start of some of your data if you're going to use the date time data type. Playing with it though, you may find some reasons to use it because like I said earlier, with the tiny int, this will help catch some really bad dates that people threw in. It can really help you with that. But you may want to use date time too if you're DBA or you're storage conscious, because the date time 2 data type is more performant. It's also smaller because they made a decent amount of changes to date time when they redid it as date time 2. So something to be aware of and play with when you're working with data. Date time 2, like I said, comes up to January 1st, the year 1, and then goes through the end of time. When I'm working normally with date time 2, I will call it out as date time 2 parentheses 7. So it will give us 7 nines here in this case. Something to be aware of. Small date time, January 1st, 1900 to the year June 6th, 2079. Those, if your data set is clean enough, then you're more than welcome to use small date time. I hope to see the year 2079 and I can actually work with it, that data, long enough to be past this. We do have 50 more years, a little over 50 more years to play with. So yeah, be cognizant of that. This will make your app just not work because it won't allow data at that point. I don't usually work with clean enough data to work with this because I have people putting in people's birth year and they're putting in the year 1753 and whatnot. So yeah, be aware of that. You cannot allow too much. So yeah, work with it. Make sure you're clean enough or your application is clean enough. If that works for you, go ahead and allow small date time. But I, on the other hand, I like date time too. It's very performant. It works great and it allows all kinds of data. I just put it back on the back end and say, yeah, you need to fix your data. Time. Time is, like they said, it is truly just time. There's no date portion to it. Yeah. Date time offsets. This one is very fun, or should be very fun for most people. Depending on where you are, this can be more than helpful. As you see here, it looks like it is just a normal date time too. But if you work at a place where they have multiple locations that are in different time zones, even if they're in the same state, there are various cases where that comes into play. For example, Florida. For any of you who have played with that data, you may have to work with the date time offsets. It can make a difference if you need to know what the true time is. It will make a difference. So yeah, play with that if it makes a difference for your use case. Then you have Texas. Always bring up Texas because it is, like we said, if it does make a difference for you, and you have to know what time zone and what place it is, then this matters. Oracle has dates. It has truly time in it as well. So you'll notice here, one of my favorite things this one does, the year negative 4712. Yes, that really is how it is, the negative 4712. So 4713 BCE. That's a lot, long time ago. Also, thing to note here, for Oracle, this one has, just like SQL Server with date time 2, it actually will allow for multiple precisions. So like I said, 7 here would give it 7 decimal places. Pretty simple. Oracle, like we were talking about in the chat, Kurt's question, this one is actually the only one that uses Julian dates, Julian calendars. So be aware of how that one is. That's how they actually get it to go back to negative 4712. Sorry, it uses the astronomical system for calculating Julian days. That's what I say here. So be aware of that. If you have to play in Oracle, dates can be a lot larger than you think. Allow for more dates than you think. And I want to also bring up Snowflake. Snowflake is fun because this is actually how at least I have made it always work in Snowflake for a date. If we do the American version of dates, it may or may not work. Play with it. As always, sometimes it won't. I've had various cases but this works every time. So year, month, day. As you see, maximum is this one. Thing to note here, you can actually put the year 0. Don't know why you'd want to put the year 0, but it's possible. They're allowing it. Yeah. Date time in Snowflake is the year 0, January 1st, year 0. And then the time of 0, it goes up to 23, 59, 59, and then the date time offset as well. So if you're in Greenwich Mean Time, CMT, whatever, that's where that comes into play. With that, I actually have another demo as well. So with this, we can actually do this in SQL Server. I like showing it this way, partly just so for our European and Asian friends, we all understand what this one means pretty quick. And it makes it, to me, it makes it a little easier. I've gotten to this format as well. As we'll see here, it truly is, this first one is January 14th of this year, then July 11th and July 21st. So let's first see what the difference is. Well, first, actually, let's do this by hand. We can figure out what these dates should be or what we're trying to get the answer for. So the first one, we just want to see how many months are between date 1 and date 2. Well, so when we look at it, we can see that it's almost 6, not quite. So in reality, this answer should be 5 point whatever. For date 3 versus date 1, that's over 6 months. That's what we're expecting. What does SQL Server give us? 6 in both cases. Is it right? Is it wrong? Close. Does it make a difference in your case? You gotta ask, because it can be slightly wrong. If you have to know, for example, somebody's birthday, when somebody turns something, and these numbers are close enough, there's a point where it will flip. And there is nothing worse than saying that somebody, especially to their face, is so old and it's not right. Then you have customer service nightmare. Yes, I have run into that. We also have, for some calculations for insurance, this one makes a difference. You have to have the right years. So I want to let y'all figure out some of the ways. There are various ways. I've heard anything from getting the number of days and then dividing by 365. That's not always correct, but it's correct most of the time. If you have a birthday because of the leap years. If you don't mind that, then it works pretty well. There's some other variants you can do as well. There's online, I am sure there's like 300. And then everybody's favorite friend these days, ChatGPT or Copilot, either one can give you variants of answers. Go for it. Figure out the one you like the best and that works in your case. It's all good. All right, so down here, I actually want to show a couple of things and then we'll try to get through the rest of it, this presentation. Goes pretty quick here. Then I'll leave some time for questions and answers. So select get date. We all know what that does. We have these 5 we've seen most of the time. As you'll go through here, you can actually figure out which of the data types that I've talked about before is what's here. You'll notice this one is date time offset. As you can tell by the fact that it's just date time offset. These are normal functions in SQL Server. Be sure to play with them, see what you like. All fun. And also notice that these two are actually UTC. So you'll get the UTC equivalent, so it won't be in your time zone. If you work with that data, it's very important to be aware of those data points as well. So other data types in SQL Server, we have binary and var binary. Fixed binary is obviously the fixed length of binary data. Var binary is the variable version of it. There's a length of 1 to 8,000 for this is how big it can be. I have a very quick demo for that as well. All right. So we're going to hit header. We define the binary variable as binary 2. Let's set it to 1, 2, 3, 4, 5, 6. We're going to add 1 to it, and then we're going to cast it as an int to see what we get. So everybody thinks 1, 2, 3, 4, 5, 6. It should be 1, 2, 3, 4, 5, 7 because we added 1, right? You know, that's not how this works. Binary does not equal int at all because as you'll see when I come back over here, if I get rid of the add 1 to it, it's definitely a different number totally. It's because it's binary. That is a trick some people will play on you, or you can play on your friends when SQL Server, because I know I like to play tricks on friends, especially when I'm working with SQL Server. Other things here are SQL variants. There's a fairly new, not a lot of people got to play with those. GUIDs, unique identifiers and GUIDs. If you haven't had to play with those, get ready because you will at some point in your life. XML and JSON are also 2 big things to play with. If you haven't got to play with those are just big databases themselves. You can store all kinds of data in there as well. When I get to geometry and geography, those are also data types you'll see pretty recently, more and more in there. You'll see that. I like to bring these up because geometry and geography are actually use CLRs behind the scenes. If you haven't had a chance to play with CLRs, they're somewhat fun, and I say that very haphazardly. Be aware of how they work behind the scenes. XML was truly a brand new data type. They did a lot of stuff to get it to work. They actually added flower into it. If you've had no flower, it works great for XML data types. JSON, though, which came after XML, they got tired. They must have, because they actually just went and they renamed VARCHAR and just called it JSON for some reason. There's nothing for it. So it's not performant. It doesn't do anything. I'm not trying to persuade you against it. I just don't use it. That's my rant on SQL Server for today. Snowflake has some other funs as well. Has objects and arrays. those are both JSON style. Arrays are normal arrays. You'll see some work with there, and they do very good work functionality-wise. Objects work great as well. Geography works how you think it does with Snowflake. Variants, I want to talk about variants for just a second. Variants can hold JSON. It can hold XML. It can hold Parquet. If you've had to play with Parquet, you should be excited by this one. It can also hold Avros. So if you're working in Kafka and you work with Avros all the time, this variant can hold it in Snowflake. It's just anything that's semi-structured, it works for that. Also, Oracle has these types as well. Just kind of throw under other. Objects XML type, which is just for XML. Row ID, which is the equivalent of GUIDs. And then you have JSON and geometry. With that, I have come to the end of my slideshow. Sorry it took a little bit longer than I expected. I'm just 1 minute over. If you have any questions, now would be a great time to ask. Make sure if you have any questions, be sure to reach out to me on email, LinkedIn, or my website, sherpadata.com. So the IDE I was using, if you'll notice, it is back here. That is SSMS 21. I'll actually show about 21.4.8 is what I'm using. 21 is where you get to have the fun of dark mode. It's great. I actually work with 2 different versions. Well, I work with the same application, but I have it set on mine so that when I log in as my SA account, I actually show it as keep my screen white so I can tell the difference very, very easily between my SA account and my normal account. So that's where I like to play with this. This version is great for that. Makes this much easier. Yes, you'll notice here, there is a Copilot in here as well. If you have thoughts on that, on Copilot, now is the time to play with it because they're just starting out and they're making great use of it as well. Any more questions? While you're thinking of very last questions, I want to remind everyone that we have DBA Fundamentals has another upcoming presentation next month. That is, let's see here real quick. Upcoming. Oh, we have one next month anyway. Dennis Torres is talking about something. I don't remember his Dennis Torres. I know that for sure. All right. So with that, if anyone has any questions, I'll be hanging out here for a few minutes. Please be sure to ask your questions if you have them, or reach out. Like I said, I'll show my ending screen. If you have any questions, be sure to hit me up, at least on LinkedIn. Make sure you can see all my goodness. I throw lots of things about SQL Server, Snowflake, or Oracle out there. And my website has a whole lot of stuff as well. So with that, thank you all very much. Have a great day, and we will talk at y'all soon.
Hey, Kevin, question for you.
Sure.
I'm wondering if it operates similarly in the cloud.
Yes.